Welcome everyone to HydroMaster's CDS xDrive service training video series. In this video series we're going to be covering the systems and subsystems of the CDS xDrive and why it is unique when it comes to direct drive truck mounts. We won't be covering some of the standard components of the CDS like the pumps, the blowers, the heat exchangers. Those components are covered in depth in other videos. So first, let's talk about safety. So in this video, we're going to cover some of the hazards that may be encountered while working on the CDS xDrive and how you can effect repairs and do maintenance in the safest way possible. We're also going to talk about some of the safety equipment that it's good to have on hand when working with this equipment. We're going to talk about the three main risk categories and how to minimize the risks while working on the machine. We're also going to talk a little bit about the Ford Transit's battery and how to safely handle them. The xDrive is designed, as all HydroMaster products are, to be as safe as possible. But to a large degree, safety relies on you. It relies on the person that's operating or repairing the equipment. Here's a quote that I like from Jeff Cooper. He's a gun safety expert, and he said, "Safety is something that happens between your ears, not something you hold in your hand." So remember, safety is up to you. So let's talk a little bit about safety equipment. So before starting any maintenance or repair procedures, it's good to have a few things on hand. Proper safety equipment, PPE. Here are a few of the recommended safety items while working with this type of machine. Certainly rubber gloves, insulated tools. Just one note about insulated tools. If you go to buy insulated tools, they are very expensive. You can do your own insulating of your tools with tape or some of that plastic dip, or much less expensive. You have safety glasses at all times, hearing protection. The machines are quite loud. Eye wash station, a fire extinguisher, and a spill cleanup kit. So these are just some good overall things to have on hand, really for any repair of any machine, but in particular this CDS xDrive. So let's take a look at some of those hazards. The first one we're going to talk about is mechanical. So mechanical safety. A truck mount, any truck mount, has a number of rotating parts and hot surfaces. Care must be taken when doing maintenance or repairs on the components and the different systems. So here are a few safety reminders about rotating equipment. So keep your fingers and your hands away from all rotating components and belts. Don't wear loose clothing or gloves that can get caught in belts or pulleys. Remove all jewelry from hands, wrists, around the neck. Don't run the machine without the protective covers in place. However, if diagnostic procedures must be performed with covers off, ensure that all safety precautions are followed. Be sure and secure the vehicle. Position the vehicle on level, clean surface prior to starting any work. Place wheel supports or wheel chocks under the vehicle tires. Make sure that the vehicle is in the park position. Engage the vehicle parking brake and position the vehicle so that the engine exhaust doesn't enter your workspace or nearby buildings or windows. There are a number of hot surfaces when working with, again, any truck mount, and that includes the CDS xDrive. You want to wear protective clothing and gloves when you're working near the different parts of the equipment, even the vehicle, like the vehicle engine exhaust, blower exhaust, cooling hoses, the engine cooling hoses, the machine motor, so the xDrive motor and the xDrive generator are also hot, and the hoses going to and from them. The case, the outside of the motor and the generator are also very hot. Another thing to remember is the weight of these components. Many of the components are quite heavy. The motor and the generator themselves weigh approximately 50 pounds each. So you need to be careful while lifting them. And certainly the heaviest component is the blower. That's 168 pounds. So again, be careful. Get someone else to help you. Use a lift. Hearing protection. It's always good to have hearing protection when working with the xDrive, particularly if it's going to be running. The machine itself can produce up to 100 decibels within about 2 feet of the front of the machine. So hearing protection is always good. So let's also talk about a little bit about electrical safety. The xDrive uses 2 separate voltage systems. Like the standard CDS, the xDrive uses the van's 12-volt battery source to power the dash and other accessories in the truck. But unlike the standard CDS, the xDrive has a separate 48-volt electric drive system that powers the generator and electric motor inside the console. Electrical hazards generally fall into 2 different categories. The first one is electric shock. So shock hazards are actually minimal with 12-volt DC systems, and even with 48-volt DC systems, since the electrical resistance of dry skin is actually very high, almost 100,000 ohms. The electrical resistance of skin goes down significantly when it's wet, goes down to about 7,000 ohms, but still the result is very low current capability at those types of resistance. So just as a way to understand what that feels like, so 100,000 ohms and a 12-volt system would result in 0.12 milliamps of electrical current. So they say that anything below 1 milliamp you can't even feel it. It's imperceptible. They say between 1 and 5 milliamps, you'll get a little bit of a tingling sensation. Between 5 and 10 milliamps, there's a slight discomfort, starting to get into the pain region. Between 10 and 20 milliamps, that's when your muscles start to contract. Between 20 and 100 milliamps, those are the voltages, or the currents, that they say can be fatal. But getting back to the resistance of skin, even at wet skin, 7,000 ohms, in a 12-volt system, that only equals 0.58 milliamps. So still even below the ability to feel it. In a 48-volt system, though, you get to the point where you're actually going to start feeling it. So wet skin, 7,000 ohms, 48-volt system, you actually have about 6.8 milliamps of current. So that you will feel it, a little bit of discomfort, but still very, very slight. So the lesson is, I guess, don't lick your fingers and grab the 48-volt bus bars. You might get a little bit of a shock. The other thing to be concerned or aware of is burns from electrical shorts. Burn hazard is more of a personal injury issue than any voltage in the system. Localized heating due to electrical shorts or arcing can result in surface temperatures in the thousands of degrees. An arc flash, so the flash that you see when 2 pieces of metal come together that are electrically charged, arc flash can be in excess of 35,000 degrees Fahrenheit. And this is why you can actually arc weld with a 12-volt car battery. Arc welding only requires about 6,000 to 10,000 degrees Fahrenheit. We need to be careful about not shorting anything out and seeing these very high temperatures that can cause burns. Here's some just general electrical safety recommendations for both voltage systems, the 12-volt and the 48-volt system. So again, always use gloves whenever possible, rubber gloves. Latex gloves are good as well whenever you're working on any type of electrical. Use insulated tools whenever possible when working with electrical components. But the first and foremost thing probably is always disconnect the power source prior to starting an electrical work on any system. The 12-volt system can be disconnected by removing the negative battery cable at the van's battery. The 48-volt system has to be discharged prior to disconnecting the negative cables from the capacitor pack. And we'll go over that a little bit later in this video. Here's a little video that this guy did about what it feels like to get a certain amount of voltage either through your skin. In the case of the video, he puts it on his tongue, so it's kind of interesting. So I'll go ahead and watch that. So let's talk a little bit about batteries and capacitors. The Ford Transit, its 12-volt battery, is a sealed lead-acid battery. As with all automotive batteries, you always want to observe the following precautions when working with lead-acid batteries. First of all, consult the owner's manual from the vehicle owner's manual for any instructions and safety precautions concerning batteries, vehicle battery. Always wear the proper protective equipment. You always want to protect your face and your hands whenever working with batteries. They do have acid in them. Always work in a well-ventilated area because they can give off fumes. Keep away from any sources of ignition, flames, sparks that can cause the battery to catch fire or even explode. The Ford Transit battery is vented to the outside of the vehicle. It's actually inside the vehicle, but there is a vent to the outside of the vehicle. There's a small tube that goes down through the floor. So make sure that tube is always secure and in place following any repair procedure involving battery. Always follow Ford's charging and jump starting procedures. There are specific procedures for jump starting, particularly the Ford Transit van. Since the battery is on the inside of the cabin, they have you charge and jump start actually from the engine bay. We'll go over some of that later. Always use care when working with batteries with tools, any metal tools or anything metallic that could conduct electricity between the two poles could cause sparks or shorts, which is also very dangerous. And then if you do come in contact with the battery acid, certainly flush the area with water and then seek medical help as soon as possible. So the battery on the Ford Transit, as I said, is inside the cabin. It's actually below or underneath the driver's seat, in the seat pedestal. The battery is either, as I said, either a sealed lead acid or an AGM. Both batteries are capable of very high current flows. Most batteries, automotive batteries, have at least 800 amps worth of capacity. So be very careful when working with the battery terminals so that arcing does not occur. Burns can also happen, as we talked about, from these high current arcs. So be very careful. Many maintenance and repair procedures require that you do disconnect the negative cable from the battery. The negative battery terminal is accessible by moving the driver's seat all the way forward, tilting the seat back forward as shown in these images, and then accessing the battery case, battery box that's below the seat. So to actually remove the battery, so if you had to take the battery completely out, they do have a procedure as well for that. So to remove the battery, if it has electric, if it's got power seats, they say to raise the driver's seat to its full position. There is that image on the left, item number 3. There is a little cap on the front of the rail, the adjustment rail, that pops off, and then that bolt number 4 is actually the stop for the front stop for the seat. So they say to remove that bolt, and then the seat will actually slide farther forward than it usually would and expose more of the battery in the back. So take out the bolt, take out the stop, and then move the seat as far forward as it'll go. So then you remove the battery clamp that's in the image on the right, number 6. It's actually a little metal clamp. There are 2 bolts to number 5 there in that image. 2 bolts holding that clamp down, then it just pulls up and pulls out towards the back. There's a little cover. The image shown on the left is actually from a dual battery system. If it's a single battery, that little cover will be on the right-hand side of that image. But open that cover, that'll expose the negative battery terminal, and then you can remove the cables from the negative battery terminal. Image on the right, there's clips that you can take that top cover off of that battery box. There's 3 clips, one on either side and one in the back, and then the cover for the battery comes out the back as well. After you've removed the negative battery cable is already taken out, you've got the cover off. Now you can remove the positive battery cable, and the battery will come out through the back. Remember, again, these batteries are very heavy, they're big, so then just pull the battery out from the back, and if you're having to replace the battery, put the battery back in the reverse procedure. So jump starting, if you actually have to jump start the vehicle, there is a certain procedure for that as well. Some of the precautions that Ford says is only use a 12-volt power supply to start the vehicle or to charge it. So if you're jump starting the battery, don't disconnect any of the cables from the battery. Leave everything hooked up, because removing the cables and trying to jump start it would actually cause some damage. Park the other vehicle as close as possible. Make sure though that the vehicles don't touch each other. That was another recommendation from Ford. The 2 points for connecting the jumper cables are shown in these images. The one on the left is the positive location that's in the engine compartment. There's the fuse box. Right on the side of the fuse box, there's a red cover. You pop that cover up, and that exposes, that's actually the positive cable, power cable, coming directly from the battery that's on the inside of the vehicle. So that's the positive location to connect jumper cables. The image on the right is where you connect the negative battery cable. That's right below the hinge from the hood on the side of the vehicle. Sometimes it has a little cap on it, so you have to pull the cap off to expose the threads or the metal where you can connect the negative terminal. So then the actual procedure for jump starting, this is the recommendation from Ford. So the image on the left, vehicle on the top is the one that has the battery that needs to be jumped. The one on the bottom is the vehicle that's actually you're using to jump start. So the numbers indicate which cable to connect in which order. So number 1, connect the positive jumper cable to the positive terminal on the van that's being jumped. Then number 2, connect the other end of the positive cable to the positive terminal of the vehicle that's actually doing the jump starting. Number 3, connect the negative cable to the negative terminal of the vehicle that's actually doing the boosting, the jump starting. And make the final connection, number 4, to the negative cable ground connection on the vehicle. That's that post that's below the engine cover. So then the procedure for jump starting, start the engine of the vehicle that's doing the jump starting, rev the engine up to 2,000, 3,000 RPM just so you have lots of voltage available. Start the engine on the disabled vehicle, so try and start it. Once you start the disabled vehicle, run both vehicles for about 3 minutes, it says, before disconnecting the jumper cables. So to disconnect them, that's the image on the right. Again, remove them in this order. Remove, number 1, the negative cable from the vehicle that you just jumped. Number 2, remove the negative cable from the vehicle that was doing the jumping. Number 3, disconnect the positive terminal from the vehicle that was doing the jump starting. And number 4, remove the positive cable from the van that you just jump started. So after you start the van that's been jump started, they say to run the vehicle at idle for several minutes just to charge it up a little bit. So I always want to be careful just to eliminate any possibilities of creating a spark that might cause some damage. So when working with the 48 volt system on the CDS xDrive, the voltage is stored in the capacitor pack. So before any work can be done on the 48 volt system, the capacitor pack has to be discharged of that voltage so that it can be worked on safely. The capacitor pack consists of 4 16 volt modules, that are connected together in series so that it creates a 64 volt capable capacitor pack. The capacitor pack is charged from the vehicle's 12 volt battery, 12 volt system while it's driving, and the charge will charge to a maximum of 48 volts. When the xDrive is turned on, the charging circuit from the van is disabled, so it's not connected to the van anymore. So any work done on the DC side of the xDrive, so that's the capacitor pack and the 2 bus bars connecting the 2 controllers, the capacitors need to be discharged of all voltage. So there is a procedure for discharging the capacitors safely. So to discharge the capacitors, you need to read the voltage. You can do that either using a voltmeter and checking the voltage between the 2 bus bars on the controllers, the B plus and the B minus, or just by viewing the voltage gauge that's on the front of the machine. Just a note about that voltage gauge on the front of the machine, it will only read down to about 5 volts and then it shuts off. They say that the capacitors should be discharged down to at least 2 volts before you actually start working on them. So to do that, the left image is this is a resistor, a power resistor. That's actually the resistor that we use on the capacitor pack, but it can also be used to discharge the capacitors. If you want to purchase one of these resistors, HydroMaster part number is 000135080. So you use that resistor and you put leads on either end, and you connect one end of the resistor to the positive terminal on the capacitor pack and one end of the resistor to the negative terminal on the capacitor pack. When you do that, you can watch the voltage start to go down either on a multimeter or on the gauge in front of the machine. When the voltage gets down to below 2 volts, you can remove the resistor. They do say to put what they call a shorting wire between the positive and negative terminals on the capacitor while you were working on them, just to prevent the possibility of any voltage being there and being able to create a spark. So that's the image on the right. Just take one of the leads and connect the positive and the negative after it's been discharged, positive and negative sides of the capacitor pack. So the CDS xDrive is designed to be as safe as possible and to both to operate and to work on. But remember, safety does depend on you. So be safe.